Okay, let's go over solving a system of linear inequalities. So in order to do that, first let's go over how to graph a linear inequality. So the first thing to look at is the sign. This is greater than or equal to. So when we graph it, we're going to make a solid line. Okay, now let's look at this part and treat it just like it's the equation of a line. So y equals mx plus b. So I guess another key point is that we want y to be by itself, so we can graph it just like we would graph a line. So 2x minus 1. So 2 is going to tell us the slope, the number in front of the x, and then this is going to be the y-intercept. So the y-intercept is negative 1. We have a slope of 2, so we're going to go up 2 over 1. We're going to constantly do that the whole time. Then going backwards, we'll go down 2 over 1. So we have our line. So now let's make that line. And like I said, it's going to be a solid line. Because the solution includes this line since it's greater than or equal to it. So just like if we had one like this, we'd shade it in if it's equal or leave it open if it's not. If it's equal, we're going to make it solid. If it says y is greater than or equal to this line, so y's go up and down, x is left and right. So if y is greater than this, it's going to be everything above it. So let's also shade above this line. So everything above this line is part of the solution. Okay, so that's how we graph a single linear inequality. We want to go over a system of linear inequalities, so let's look at another inequality. So let's say y is less than or equal to 3x, make it negative 3x plus 1. So now the slope is negative 3 and the y-intercept is 1. So let's start off at 1. And we have a slope of negative 3, so we're going to go down 3 and over 1, down 3 over 1, down 3 over 1, then let's go backwards. Okay, and again, it's, well, this one's greater than or equal to, this one's less than or equal to, but because it can equal it, it's going to be a solid line. Okay, and this time it's less than, so it's everything below the line, so it's shade below the line. It's going to continue on in this direction, so everything's shaded over here. So now the solution is going to be the set of coordinates that satisfy both of these, which in this case is this area here, so it's wherever they overlap. So we see it's defined by this area. So we can put a big S here. This is our solution. And any coordinate or any point in this area would work in this inequality and would also work in this inequality. So notice that this area is a solution to this inequality, but not to this one. So it wouldn't be in the solution set. And likewise here, this area is a solution to this inequality, but not to this one. So this area is the solution to the entire system. Something else worth noting is that points on this line up to here and points on this line up to here are also part of the solution set. Since it's a solid line, points on the line can be accepted. So this is a solution, this is a solution. All of these points on the lines are solutions. Not over here or over here though. Alright, let's look at another set. So y is less than or equal to 3 halves x plus 1. Y is greater than or equal to negative 2 over 5x plus 2. Let's start with this one. We have a y-intercept of 1 and the slope of 3 halves. So we're going to go up 3 over 2. And now we'll go backwards, down 3 over 2. Okay, now let's graph this. This time it's a less than, but not equal to. So it's going to be a dashed line. Okay, and it's less than, so it's everything below this dashed line. Alright, so this entire area is a solution to this inequality, but this line itself is not a solution because it's less than but not equal to this line. Alright, now let's graph the other one. So y is greater than or equal to negative 2/5 x plus 2. So y-intercept of plus 2 and a slope of negative 2 over 5. So down 2 over 5. Down 2 over 5. Okay, let's go the other way. We're going to go up 2 over 5. And this is greater than or equal to, so since it can equal it, it's going to be a solid line. And it's greater than or equal to, so it's everything above the line. Alright, so now let's look at the solution. The solution is the overlap. So they both overlap here, so this is our solution. Any point in this area is a solution to both of these inequalities. Okay, now let's look at the lines. This is a solid line, so anything on this line from here on is a solution. Okay, anything on this line is not a solution since it's a dashed line. We don't include points here. So the point of intersection in this case is not part of the solution. Okay, because it is a solution to this pink one, but not to the blue dashed one. But here on, we do count those as part of the solution set. And of course, anything in this area.